Alright, so in this video I'm going to look at using a model to solve two-step equations where our variable is being divided by a number. Okay, so in the other one we did with modeling, our variable was being multiplied by a number. So in this one we're looking at dividing by a number. So what I'm going to do here is, remember we've done another video like this where I started off and I kind of have my circle. And I'm using this circle to represent x, okay? And x is currently being divided or split into two separate parts. So I'm going to split my circle in half, and I'm going to show that I've got half or one of my two groups to start with. Okay, so if you think about dividing a number by 2, it's splitting it into 2 equal sections, and then we say how much is in each section, right? So if I had 10 divided by 2, it's like taking 10 and splitting it into 2 equal groups, and then both groups would have 5 in it. So I'm kind of coloring in this one piece to say I'm looking at just that one piece and how much is in that single piece there. Okay, so that represents my x over 2, or x divided by 2. And then I need to do my positive 3. So I need to add my 3 positives in here. Okay, and remember I'm not really using symbols, so I'm just using the drawings to show what's going on. Okay, and then I'm going to, on the other side, have 11 positive ones. Okay. And at some point throughout this video, you're going to see me just pause, okay, because I'm sure you don't want me to watch me sit here and draw all these things out. So at some points, I'm just going to pause, and then through the magic of video technology, I will restart the video, and then things will just appear on the screen. Okay, so just be aware that if that happens, it is intentional because I figured you'd get bored. So I've got my x over 2 right here. This represents x over 2. This portion represents the plus 3 or positive 3. And on the other side, we have our 11. Okay, now like we did with our other equation, the first thing I need to do is get rid of these constant ones. Okay, I'm going to get rid of those positive ones and move them away from the left-hand side. Now the only way I can cancel out those 3 positives is to bring in 3 negatives to make a 0 pair. Okay, so I'm going to add in those 3 negatives. But I have to treat both sides equally. So whatever I do on one side, I have to do on the other. So because I bring in 3 negatives here on the left, I also have to bring in these 3 negatives on the right. On the left-hand side, my 3 positives match up with those 3 negatives to form 3 0 pairs. And likewise on the right-hand side, I also have some 0 pairs here that are going to cancel out. My 3 white tiles meet up with 3 of those red tiles to make 3 0 pairs. And so now I'm going to consolidate the information that I have left over. So I'm just going to drag in another circle here. I'm going to draw this out again. I've got my circle that I split in half, and I colored in this side blue. Okay. Now everything that was in this section here is all crossed out. That makes a bunch of 0 pairs, and everything in this section makes a bunch of 0 pairs. So the only thing I have left is those 8 red ones. Okay, and so the way this works is we say when I have my x and I split it into 2 pieces, when I have one of those 2 pieces left over, it equals 8 ones on the other side. So 1/2 of x represents a value of 8 on the other side. Now what I'm going to do is I'm going to use kind of the same color. I'm going to say that that first piece that I colored in blue represents that group of red tiles on the other side in blue. And what happens next is when I color in my next section, because I really want to get x built back together. I want to get all of x back together. Instead of thinking of it as these smaller separate groups, I want to put all the groups back together. So when I color in my next section green, that green section is the same size as the blue section. So that means I need to have another group of tiles that are going to match up with that green one that I just colored in. And in order to do that, that means I need to add in those 8 red tiles. So I've got a group of 8 red tiles that matched up with my blue grouping, right? And then I've got a group of 8 red tiles that match up with my green grouping, right? So because I split X into 2 equal parts, my first half of X matched up with these 8. That means the other half also has to have 8 in it as well. And so what this gives me now then is X, when it's all colored in, gives me 16 in total. So that would be my missing number. And that kind of makes sense. If I think of putting this number back in, 16 divided by 2 would give me 8, and then 8 plus 3 would give me 11, and that's exactly what I should have. Okay, so let's do another one of these. I've got X divided by 3 this time, plus 5. X divided by 3. So I'm going to start by dividing my X, and I like to think of it as a circle in this instance. Now, however, if you want to draw it as a rectangle and split your rectangle into 3 parts, that's absolutely fine. I tend to work with X as a circle if I'm going to be splitting it, just because, mostly because I like pie and cake and pizza, and that's what this makes me think of. So I'm going to split my circle into 3 separate sections. I'm dividing it into 3 equal groups or 3 equal spaces. And when I divide by 3, I start off by looking at just how much is in one group. Okay, the rest of it, I need to add in 5 positive 1 tiles and a negative 1 tile on the other side. And again, I am just going to use some video magic so you don't have to watch me draw everything. So you can see that now I've got my 5 positive 1s here on the left-hand side, and then I've got my 1 negative 1 on the right. So this circle right now represents the X over 3. These red 1s represent the positive 5. This line represents the equal sign, and then on the right-hand side, that white square represents negative 1. So my first step is I've got to get rid of these extra 1s. I don't want these 1s hanging around on the right-hand side. So because I have 5 red 1s or 5 positive 1s, the way I cancel that is by adding in 5 negative 1s. Now remember, when I add in those 5 negative 1s on the left-hand side, the way that I make sure that this stays equal, I need to keep my equation balanced, so I have to treat the right-hand side the same. So it also needs 5 negative 1s on that side as well. So you can see here that I've added 5 negative 1s on the right as well as the 5 negative 1s on the left. So I added these guys in, and I made sure to keep both sides equal. I treated both sides the same because if I'm going to change my equation, I have to do the same thing on both sides. Okay, so now what I'm going to do is I'm going to kind of rewrite what I had here. So I've got my X, which we had split into 3 pieces, and we colored in that first piece. Okay, now the other stuff on the left-hand side is now actually nothing because I have my 5 positives and my 5 negatives, and that just makes a big 0 pair. There's nothing else left, so I'm only left with my circle on the left-hand side of my equation. Now, I'm going to be bringing in my 6 negatives because on the right-hand side, I was left with those 6 negatives. There was nothing that canceled because they were all the same type of thing. They were all the same color. So when my 1 blue piece is colored in, I have 6 negatives on the other side here, right? So I took X and I split it into 3 smaller pieces. And when I looked at just one of those pieces, it equals 6 of those negatives on the other side. And what that means is as I color in another piece, well, another piece of the puzzle is going to still be the same size. So when I bring in that green section and I color in that green section, that means I also need to add 6 white tiles or 6 1s in for that piece as well. So now I get my 6 green tiles. to represent that second piece that I colored in. And now when I color in my third piece, this third piece must also be an equal-sized group. And so when I bring in that third piece, the same thing happens. I need 6 more of my -1 tiles, these little white squares, so I bring in 6 of those to match up with that yellow grouping. So you can see X, when it was all colored in, I had 18 tiles, but when I split it into 3 smaller groups, each group got 6 of those ones in it. Okay, so that's kind of what I'm undoing here. Now, in total, now I got it colored all in, I've got X, and on the other side I have 18 ones, but they're negative because they're blank, they're white, they're not colored in. So we've got X is equal to -18. Okay, now, we do need to be careful because sometimes these things change around a little bit. So with this one where I've got X over -4, so I am still going to split this one into 4 pieces. Okay, I'm going to start off again by saying one of those pieces is colored in blue, but one thing I have to be very careful of here is that negative sign. So when I've got X over -4, that's the same thing as -X over 4. It doesn't matter which of my 2 integers is negative, they will have the same value. So I'm going to make a note to myself and just say, hey, Mr. T, you've given yourself -X over 4 here. So when I've got everything colored in, my circle is going to be -X. Now that's not great because we don't want -X, but it's very easy to deal with that. But we just have to make a note of it so we remember to be paying attention to it. Okay? Now again, through some shoddy video magic, I've added in my 9 white tiles to represent my -9. So this is my -9. And on the other side, I've got my -1. Now, how I get rid of those 9 negatives is I'm going to need to bring in 9 positives. Now, when I bring in those 9 positives, okay, I need to make sure that I do the same thing on the left side as I do on the right side. Okay, so I bring in my 9 on the left, and the reason I'm bringing in 9 is because I need to cancel out those 9 white tiles that we have, and so I got to cancel those out with the 9 red ones. Doing the same thing on the right-hand side, I am going to get to cancel a little bit out on the right-hand side because I already have a white tile, and so one of my red ones is going to cancel that white one, but we're going to have some positives left over. So this one here, everything here has a pair that matches up. This makes one giant 0 pair. And on the right-hand side, one of those red tiles cancels out that one white tile. One of my positives cancels out that one negative, and I'm left with those 8 positives. And so now you can see as we move down to our next step, everything on the left-hand side disappeared except for our X, right? So we've got our -X over 4, and there are 8 ones left over on the right-hand side. So when that blue section is colored in, we get those 8 positives. So when one of our smaller sections is there, we've got 8 positives. And then as I color in another section green, I add another section or another green group of 8 tiles. So each color, then I get a matching group that has the same amount, right? So when I color in that next section green down here, I add 8 more green tiles. And now I'm going to color in this next section yellow, and I'll get 8 more tiles to match up with the yellow one. Now the last thing I'm going to do is I got to color in that 4th section so that my whole piece is colored in. So I'm going to color this one in red, and I'm going to add another section of red that has 8 tiles in it as well. Now I've got everything all colored in on my X, right? All 4 colors, each 4 sections, and you can see each colored section has a matching group of 8 ones in it. Now the only problem that I have here is I said -X is equal to +32, and that's a problem. I don't want -X. -X is bad. I don't want that. I want -X to always change to +X. So if I'm going to change my sign in front of X like this, I need to change it to being +X. So I'm just going to flip it to +X. Now, whatever I do on one side, I have to treat the other side the same. So if X has flipped its sign, then the integer over here is also going to flip its sign. So it goes from being positive to being negative. So if negative x is positive 32, that means that positive x must be negative 32. Now I could show that in my model by simply just flipping colors or saying now, okay, I'm going to change it to positive x. And then I would have to take everything on the right-hand side and flip their colors, but that's definitely too much writing that you don't want to see me do. Okay? So that's how we use our model to solve. Now, the last one, I'm going to leave it up for you. I want you to, I didn't write it, because why would I want to have the forethought to do any of that before showing you the slide? Now, I have modeled an equation here, so your goal is to look at it and say, well, what is the model that Mr. T's put up here? And then try to complete the model. So I'll just pause myself, and then you'll see that it just kind of pops up at the end screen if you want to double check. So that would be good practice for you. So that's modeling two-step equations where our variable needs to be split into smaller pieces. So there is a difference between when we have x is being divided by something and when x is being multiplied by something. But when you look at the way we solve them both algebraically, you'll actually see that we've got some really close similarities when we are looking at our solving. All right, so that is modeling two-step equations.